Today we're going to learn about greatest common factor. It is the greatest, or also known as the biggest factor, that is shared by two or more numbers. One way to find the greatest common factor of two or more numbers is by listing factors on a T-bar. We're going to do a T-bar for 24 and 40. So when we list the factors, we always start with 1 in itself, so 1 in 24. 2 will work because it's an even number, so 24 divided by 2 is 12. We check for 3 by doing the sum of the digits. 2 plus 4 is 6. 6 divided by 3 will work, so 24 divided by 3 is 8. It is an even number. 2 works, so let's do the 4. 24 divided by 4 is 6. 5 will not work because it doesn't end in a 5 or 0. So our factors for 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Now let's do the T-bar for 40. We always start with 1 in itself, so 1 in 40. It is an even number, so 2 will work. 40 divided by 2 is 20. 3 will not work because 4 plus 0 is 4, and I cannot divide 3 into 4. 4 works because it is an even number, and 2 worked, and so once you try it out, it works and it makes a 10. 5 works because it ends in a 0. 6 will not work because even though the 2 worked, the 3 did not. 7, nope, doesn't work. We already have the 8, so we're done with our list of factors. 1, 2, 4, 5, 8, 10, 20, and 40. Now let's see about all the factors that 24 and 40 have. They both have a 1, they both have a 2, they both have a 4, and they both have an 8. Which one is the greatest? It is 8. Now, another way that a lot of people may want to figure out the greatest common factor is maybe on a Venn diagram. If you know that 3 times 8 is 24 and 5 times 8 is 40, you will see that 8 they both share in common. And so you could put that in the both section of the Venn diagram. That leaves the 3 for 24 only circle and the 5 for the 40 only circle. So we will not use the 3, we will not use the 5, and we will only use the one they both share in common, which is an 8. So this is another example how you can show that the greatest common factor on a Venn diagram is 8. A factor tree is another way to find the greatest common factor by using prime factorization of 2 or more numbers. We're going to do factor trees on 42 and 8. 42 is an even number, so let's start with 2. So 42 divided by the 2 makes the 21. 2 is prime, so that will be the end of that tree. 21 is composite, so we make another tree branch and get 3 and 7. Now, we bring down the 2 from previously, and now we have the prime factorization of 42 because 2, 3, and 7 are all prime numbers. So 42 equals 2 times 3 times 7. Now let's do the factor tree for 8. We need 2 factors that make 8, so let's do 4 times 2, which makes 8. 4 is composite, so we're going to make a tree branch for that, and we get 2 and 2. And then 2 is prime, so we're done with that tree branch. So now we have 2 times 2 times 2, so 8 is 2 times 2 times 2. They both share a 2, so the other prime numbers do not work, so the greatest common factor is 2. Greatest common factor may be found by using the prime factorization of 8 and 12 using a factor tree and a Venn diagram. When you look at the prime factorization of 8, it is 2 times 2 times 2. 12 is 2 times 2 times 3. Now we look to see what they share in common. They have 2 sets of 2's. So we're going to put those two sets of 2's right here in the both category they share in common. And then the 2 and the 3 for 8 and 12 is the leftover. So 8 only would be this 2 right here. And then for 12 only would be this 3 right here. We're not going to count the 2 or the 3, so we're going to times the 2 for both. 2 times 2 is 4, so the greatest common factor is 4. We're going to use a real-life application problem when showing the last way to find greatest common factor using prime factorization. It is called a prime factorization ladder. This is actually my favorite one to use. I will show you how to do a prime factorization ladder after we read the real-life application problem. You are making balloon arrangements for a birthday party. There are 16 white balloons and 24 red balloons. Each arrangement must be identical. What is the greatest number of arrangements you can make using every balloon? And they give us a hint. Greatest number arrangements means greatest common factor. All right, so first thing we're going to do is we're going to put the 16 white balloons on the ladder. So here's the 16. And then we're going to do the 24 red balloons right here on this part of the ladder. So 16 and 24 is on the top of our ladder. They are both even numbers, so we want to start with the prime number 2. 16 divided by 2 is 8. 24 divided by 2 is 12. We're no longer going to use the 16 or the 24. We're going to now use the 8 and 12. Those are both even numbers, so we're going to do 2 again. 8 divided by 2 is 4. 12 divided by 2 is 6. So now we're no longer going to use the 8, 12 or the 16 and 24. We're now going to use the 4 and the 6. So they're both even numbers, so let's divide by 2 again. 4 divided by 2 is 2. 6 divided by 2 is 3. Now 2 and 3 are both prime numbers and they share nothing in common other than a 1. So now we know we are finished with our prime factorization. So what is the greatest common factor of 16 and 24? Well, you're going to times all of those 2's that you divided out of 16 and 24. So 2 times 2 times 2 makes 8. So the greatest common factor is 8. So that means we're going to have 8 arrangements. But do you know how many white and red balloons are in each of those 8 arrangements? Well, just look at your leftover and that will let you know. Now think about it. If you have 8 arrangements and you times it by 2 white balloons, you're going to get 16 white balloons. The same goes with the red balloons. If you have 8 arrangements and you times it by 3 of those red balloons, you get the 24. So the answer is 8 arrangements, 2 white balloons, and 3 red balloons in each of those arrangements. Now it's time for you to try to solve a problem on your own. It states, select each true statement about the numbers 132 and 168. When it says select each true statement, that means there's going to be more than one answer. So let's look and see what all 6 choices are. A, the number 2 is a common factor. B, the number 11 is a common factor. C, the number 6 is a common factor. D, the greatest common factor is 3. E, the greatest common factor is 12. F, the greatest common factor is 24. So we have 3 of our answer choices asking for common factor, and we have 3 of our answer choices asking for the greatest common factor. Also, we notice we have 3 numbers that are prime numbers and 3 numbers that are composite numbers. So with that said, you have to make a decision on what method to use. Are you going to use a T-bar method, maybe a prime factorization tree with maybe a Venn diagram, or a prime factorization ladder? If you answered that you should use a T-bar and the common factors are 2 and 6 with the greatest common factor being 12, you got the correct answer. Let's look and see why A, C, and E are the correct answers. Our lists of common factors of 132 and 168 are on the T-bars. 1, 2, 3, 4, 6, and 12 are all they share in common as common factors. Of those, we see that C has 6 as a common factor and 2 as a common factor. And the largest of all those factors is 12. So that's why the greatest common factor is 12. Just remember, there is more than one way to solve for greatest common factor. Sometimes it will be easier to do prime factorization using factor trees, Venn diagrams, or maybe the prime factorization ladder. Other times, like on this example, it would be better just to list all of the different factors on a T-bar using your divisibility rules to find the greatest common factor.